Like a zombie.
Okay. Go.
The last two exercises deal with Chapter 9, which I'll be covering next week. Last week, hurrah. Okay? We're going to be doing Z hypothesis test and T hypothesis test. The basic gist of a hypothesis test is we're given a particular mu, population value. We're going to ask, is that population value going to fall within the given confidence interval or outside the given confidence interval? In terms of hypothesis testing, that's whether you accept the null hypothesis or reject the null hypothesis. If we accept the null hypothesis, that means that the given mu is likely to fall within the given confidence interval. If we reject the null hypothesis, that's saying that the given mu is likely not to be in the given confidence interval. Depending on if we're given the population standard deviation or not given this population standard deviation, it's either going to be a Z hypothesis test or a T hypothesis test. First, this exercise does the Z hypothesis test where we're given the population standard deviation. I'm going to be doing problems 72 and 76 on page 388 and 389. Problem 72 does hypothesis testing without a list. 76 does hypothesis testing with a list. So to begin, looking at number 72, okay, what we need is to enter the data in the hypothesis test function. To access that, you hit your stat menu, arrow over the test, and number 1 is your Z test, number 2 is your T test. We're going to do a Z test. Arrow over the stats again when the information is we're going to have to type in. In problem 72, the null hypothesis mu of 0 is 22. So we type in 22. Arrow down to the population standard deviation. Population standard deviation for this particular problem is 4. X bar. X bar for this given problem is 20. Let me think about that for a minute. N, okay, is 24. And the test we're doing is mu is not equal. Now we'll talk about that later. Not equal means there's air on either side of the normal curve. Less than, all the air means this is to the left. Greater than means all the air is to the right. We'll talk about that in chapter 9. Right now we're looking for on either end. Hit calculate. It's going to give you your Z value and your P value. The P value, Z value is what the Z value would be on the table. Notice it's pretty low. Okay, the P value is important because if P value is used to determine whether or not you accept or reject the null hypothesis. If the P value is less than the alpha level would be if you have a confidence level of 95%, the alpha level is 1 minus 0.95 or 0.05. That's the alpha level on these problems, 95%. So the P value, 0.01, is less than the alpha significance level, which is 0.05, which means we reject the null hypothesis in favor of the alternative, meaning that the mu is not going to fall within the given confidence interval. Number 76 does the same thing, but we have to enter the data. Okay, so what we first got to do is hit our stat menu. You turn to page number 76 on page 389. Okay, I'm going to go in and enter the data. Clear out my old data. Okay, and so we're looking down, we start with 60, enter, 58, enter, type all the information in carefully. When we're done, on this particular problem, they want a 1% significance level, which means our confidence level is not 95%, it's 99%. So when we're done here, hit stats, arrow over to test again, select one, you'll have to select data. Okay, mu of 0 that we're testing in this problem is 12 people. It says, if you look at the problem, it says, does it provide sufficient evidence to conclude that the mean age of diagnosis of all people with early onset is less than, not equal, is less than 55 years old. So the mu of 0 is 55. Okay. Population standard deviation, okay, given here is 6.8 years. Again, this is a z-test, so it should give it to us. L1's the list. Now, because it's asking for is less than, we have to arrow over to less than mu of 0. It means the error region is all to the left, not on both sides. Hit calculate. It's going to give us a z-value and a p-value. Z-value, notice the z-value and the p-value are related to each other somewhat. Z-value is minus 1.66. The p-value is 0.095. 0.095 is greater than 0.01, okay, because the significance level is 1% or 0.01, so that means we accept the null hypothesis, which means we expect that the mu of 55 to fall within the confidence interval that we can generate with this problem. This concludes my tutorial on z-hypothesis test.